Hey y'all, I wanted to make a quick video because we had a short class today about balancing chemical equations. You guys are working on some equations on a website that I provided to you in class today, and since we had such a short time in class, I just wanted to go over the process and remind you guys about how do we balance an equation. The first thing that I want to go over is the structure of a chemical equation. We have to remember that chemical equations are all written in the same format. Anything that's in the front of the arrow is a reactant, and these are the things that are going into the chemical equation, same as going into the reaction, because you remember that a chemical equation is just a representation of an actual reaction. So we have reactants, and then we have our yield arrow, and then we have products. Those are the things that are going to be produced when these reactants mix together. Okay. So we started off earlier this week with really simple chemical equations. Like we would figure out that the product sodium chloride was made of sodium plus chlorine. And we figured out that chlorine was a diatomic element, so it's always found in pairs. And now our equation is unbalanced, so we have to figure out how to balance that. To do so, even in these very simple ones, we made a list of our atoms involved in the equation. Then we counted the number of atoms on the reactant side. So for sodium, there's 1. For chlorine, there's 2. And then we counted our number on the product side. Here we have sodium at 1 and chlorine at 1. Okay? So now we can see an imbalance, that on this side of the equation I have 2, and on this side of the equation I have 1. This does not allow for conservation. Remember, we talked about the law of conservation, and we said that we can't create or destroy matters, so we can't create or destroy atoms. And so here I have 2 chlorine atoms, but only 1 over here. So I can't destroy matter like that. I have to balance my equation. To balance this equation, I would figure out how I can make this 1 turn into a 2 using a coefficient. If you remember, a coefficient is a number that we use to multiply by the atoms that are in the compound, and that tells us how many of that compound we have in this equation. So if I want to get 2 chlorines on this side of the equation, I'm going to have to multiply my chlorine containing compound by 2. So I'm going to put a coefficient of 2 in front of the chlorine containing compound on the product side. That changes my chlorine count from 1 to 2, and that also changes my sodium count from 1 to 2. So now I need to balance my sodiums. To do so, I need to have 2 sodiums on this side of the equation. I have 2 over here, I need to have 2 over here. The only way to do that is to place a coefficient of 2 in front of sodium, which is going to apply to this sodium atom. Instead of having 1 sodium atom, now we have 2. Okay? Since there's not another atom here, this coefficient doesn't apply to that like we had for here, where this coefficient applies to this sodium and this chlorine. So now that we have sodium balanced on either side, we have chlorine balanced on either side. That means that this is a balanced chemical equation, and we would read it like we would read a sentence. The sentence would read like this: 2 sodium atoms plus the chlorine molecule, the diatomic chlorine, yields 2 sodium chloride molecules. Okay? So we get 2 sodium chlorides when we mix 2 sodiums and 1 chlorine molecule together. Okay, so I know what you guys are going to say. Miss Latner, this equation is far easier than the ones you gave us in class today. That's true. We worked our way up. We did ionic compound equations where we had elements come together to form ionic compounds. Then we also did covalent compound equations where we took a covalent compound and we broke it down into its parts, okay? Now we're moving on to larger equations. What I want you guys to focus on is that no matter how many atoms are in an equation, we do it the same way we did our very simple equations, okay? So I did what I asked you guys to do in class today. I got on the same website. I asked it to generate 5 equations for me. You guys did 10. I'm going to do 5 in this video, hopefully. And I'm going to do these equations just like we did the more simple equations in class, so that you guys can understand that it's not about how long the equation is, it's not about how complicated the equation is. We're focusing on the process of how do you balance it and how do you make sure that you have the same atoms on your reactant side as you have on your product side. So these are equations from that website that we did in class today. So the first one that it generated for me goes like this. This is zinc sulfide. That's diatomic oxygen, if you remember, or what we might call molecular oxygen. This is zinc oxide, ionic compound. There we go. All right. And if you remember in class, we were calling this sulfur dioxide. This is a little bit more of a different name in chemistry, but we're not going to worry about it. We're going to call it sulfur dioxide, that covalent compound. Okay, so we need to balance this equation. We're going to do the same thing that we did in our previous equation. That equation was very simple. This one is a little bit more complicated. We've got more atoms, more compounds, but we use the same process. The first thing I'm going to do is I'm going to list the atoms that are in the equation. Okay, I have zinc, I have sulfur, and I have oxygen. Those are the three kinds of atoms that are found in this equation. My next step is to count how many of each are on each side of my equation. I have one zinc on this side, I have one on this side. Sulfur, I have one, and I have one. Oxygen, I have two, and I have 2, 3. Remember that this subscript applies to this oxygen, but not this sulfur, okay? So this is 2 oxygens and 1 oxygen, which gives me 3, okay? So you're like, Miss Latner, this is already balanced, this is already balanced. How am I going to get a 2 and a 3 to balance, okay? Let's look at where oxygen is found in this equation. We have some oxygen here, just one diatomic oxygen, and then here I have oxygen in 2 places. Since I have oxygen in 2 places, that's going to mean that I'm going to have to work with both of these compounds to get my oxygens to balance, okay? Now, one of the ways that I can do that is by trying out some coefficients to see what it does to my numbers, and that's what I'm going to do. Okay, I'm going to approach this as if I don't know the answer to this equation. We're going to work it out by trial and error, which is much like the way that you guys would try something. So what if I put a 2 in front of my zinc sulfide? Okay, well, that changes this number to 2 and this number to 2. Okay, now I have to balance that on my other side. Well, if I want to make this into 2, then I put a 2 right there. That makes zinc 2 on this side. This also applies to this oxygen right here, so I need to include that in my count. So now this is 2 oxygens, and plus these 2 oxygens, this side now has 4. Okay. Next, I'm going to balance my sulfurs. With sulfur, I have 2 on this side and 1 on that side. So I'm going to put a 2 over here so that I get 2 on this side. But that also applies to my oxygen. So now I have 2 times 2, which is 4, plus these 2 oxygens. So that's going to give me 6 oxygens. Okay? My last thing to balance is now my oxygens. I want to have 6 on this side and I only have 2. So the only way that I can make a 2 turn into a 6 is to multiply it by 3. So I'm going to put a 3 in front of my oxygen containing compound on this side of my equation, and it's going to change me from having 2 oxygens to having 6. So now my zinc is balanced, my sulfur is balanced, and my oxygen is balanced, which means I have successfully balanced this equation. So lessons learned from this one. First of all, it doesn't matter how many compounds are in the equation, I still list my atoms and count on both sides. I use coefficients in front of my compounds to help me balance my equation so that I have even numbers on either side. In a coefficient, it applies to everything that's in that compound. If you put a coefficient in front of a compound, it applies to the whole thing, okay? All right, let's try another equation. The second equation that popped up on my random generator was this one, iron chloride plus sodium phosphate yields iron phosphate plus sodium chloride. Okay. So you can see that this equation is a lot like my last equation in that I have two compounds that are coming together to form two other compounds. We're not going to worry about what kind of equation this is because, like I said in class today, we're not identifying types of equations. We'll leave that for chemistry. We are trying to figure out how to balance equations because in biology, we have a lot of chemistry that happens on the molecular level, on the cellular level, on the atomic level. So to understand that stuff about biology, we have to understand chemistry. All biological beings work off of chemical reactions, so that's why we have to understand chemical reactions in biology. Let's try this one. First, I'm going to list the atoms that are involved in the equation. Here is iron, chlorine, sodium, and then I want to show you guys how you can do this. Let me clean that 4 up, it wasn't nice. How we can do these, what we call polyatomic ions. Do you see how this is PO4 in the reactant side, and in the product side it's the same PO4? You can either treat that separately, like that, or what I like to do sometimes, because it makes my brain work better, is I keep it together because it's found the same way on both sides of the equation. So why break it up, okay? Now, if you want to, I can go through the other way too, but let me show you how to do this and see if you like that, okay? Now we need to count. I have 1 on this side. I'm counting iron right now, and 1 on this side. I have 3 chlorines on this side, 1 on that side. Counting sodiums, I have 3 on this side. I have 1 on this side. And then counting my phosphates, I have 1 on this side and 1 on that side. You're like, Ms. Latner, how do I know I have just 1? What if I were to put a parentheses right here? Would that make it better? Sometimes we do that with our polyatomic ions, and it helps us remember that they can move as a unit, okay? So let's start balancing this equation. Well, the only thing that I see out of balance initially are 2, so let's tackle those. I have 3 chlorines here, and I have 1 here. The only thing to make this 3 is to put a coefficient of 3 here. That was an ugly 3. Let me move my plus sign. There we go. Okay. Now that also changes the chlorine and the sodium. That changes both of these atoms. So I'm going to change both of those to 3. And now we can see that everything is balanced. And you're like, Ms. Latner, that looks like a really long equation. You're telling me that I balanced it with 1 coefficient? Yes, because the process is the same. Sometimes really long equations are super easy to balance. So don't let the length of the equation or the number of atoms scare you. It's about the process. List your atoms, count them, and then use coefficients to make them balance. Let's try another one. This is the third equation that random equation generator generated for me. There we go. Okay, so this is sulfur plus oxygen yields sulfur dioxide. We're going to list our atoms first. Sulfur and oxygen are the only 2 atoms involved in this. Count. There are 8 sulfurs on this side, 1 on that side, 2 oxygens on this side, 2 on that side. Let's balance. This is my out of balance atom, so I'm going to balance it first. I need to have 8 on the side of 1. The only way to make 1 turn into 8 is to multiply it by an 8. I'm going to put in my sulfur dioxide, and that turns that into 8. But it also changed my oxygen too, because remember, coefficients apply to everything that they're in front of. So I have 8 times 2 oxygen. So 8 times 2 is 16. So now I've got 16 oxygens over here. That threw my oxygen out of balance, so now I need to balance it. I need 16, I have 2. The only way to turn a 2 into a 16 is to multiply it by 8. So I'm going to add a coefficient of 8 here on this side of the equation, and now I have 16 oxygens there. So now sulfur is balanced, oxygen is balanced, and I have a balanced equation. This one was not so bad because it was a smaller equation, but you can see that sometimes y'all get stuck in thinking that you can only balance equations with small numbers, like 1, 2, 3. Sometimes it takes big numbers or larger numbers, not that 8 is a big number. Sometimes it takes larger numbers to balance our equations. I've gotten stuck on equations before where I'd had to put really large numbers in there to balance them. And while that might be like frustrating or hard in the beginning, we have to remember that it's about the process, that even hard equations are solvable if we count how many atoms are on each side and then use coefficients to balance them. Let's try my fourth equation for my random equation generator. This one is, not that y'all need to know what kind of equation it is, but this is a combustion equation. Combustion equations can be somewhat difficult sometimes because they have hydrogens and oxygens in multiple places, mostly just oxygen. But sometimes it's hard to balance a 2 and a 1 oxygen together, but we'll see how this equation plays out for us. And how did I know it was a combustion equation? Because this is a fuel, this is a hydrocarbon, and this is oxygen. So what happens when I mix oxygen with fuel? Boom. Carbon dioxide, water. All right, let's balance this equation. So I'm going to write down my elements: carbon, hydrogen, oxygen. Now we've seen a lot of carbon, hydrogen, oxygen over the past week and a half because I've been drilling you guys on these 3 elements. Why? Because they're the ones that make up living things. When we get into our metabolism unit, our cellular energies unit, we're going to have a lot of these combustion reactions because guess how you break down things in your body? It's kind of similar to this, except sometimes instead of using oxygen to break it down, we use water to break it down, but we'll get to that. Okay, let's focus on balancing this one. Let's count. We have 2 carbons over here, 1 over there. I have 2 hydrogens over here, 2 over there. Okay, 2 oxygens here. I have 1, 2, 3 oxygens over here. Okay, let's pick carbon. I don't know, I always start at the top. Who knows why? Let's try to balance carbon first. Sometimes that works out to my advantage, sometimes it doesn't, but you just have to work it out and see. I have 2 carbons over here and 1 over here. The only way to make a 1 turn into a 2 is to multiply it by 2. So I'm going to put a 2 in front of my carbon-containing compound on my product side, and that's going to change my 1 to a 2. Now this also distributes to this oxygen, so 2 times 2, that's 4, plus this 1, so that is now 5. Okay? I need to balance my oxygens here, but to do so, I'm going to play around with my molecule on this side. Sometimes I like to think about these like when I have oxygen in 2 places on my product side. Instead of saying 5, can't I say 4, 2 plus 1? Isn't 4 plus 1 the same thing as saying 5? So if I want to get the balanced amount of oxygens over here, I can only put a coefficient there because oxygen's not in this compound. Well, if you see, this is diatomic oxygen, so the only thing that I'm going to be able to get here to balance is going to be an even number, okay? So if I balance my oxygens, it's probably going to unbalance my hydrogens, but that's okay, we can fix that. All right, so I want to get my oxygens to be able to balance on this one. Since I have this odd number of oxygen right here, I'm going to play around with this equation and see if I can't make it balance in some way. Do you know how up here we tried a 2? What if we tried to balance it in a different way? What if we, and I'm going to reset us back to our original. Remember how I was saying sometimes I start at the top of the list and that doesn't do well for me? Well, sometimes you got to back up and go back to your original counts and try something else, okay? I'm going to try this, all right? What if I put a 2 in front of this compound, this carbon-containing compound? That gives me 4 here. It also gives me 4 hydrogens there, okay? To balance that, I could put a 2 here, and that would give me 4 hydrogens on this side, and it would change my oxygens from being 3 to being 4. Now I've got an even number. I can work with that, okay? I need to balance my carbons here, so I'm going to have to put a coefficient of 4 here, like that, okay? That also changes my oxygens though, so now I have 4 times 2, which is going to be 8, plus 2, so that's going to be 10. Okay. Now I have an even number. Yeah, we got it. We can do this now. I want to make my 2 turn into a 10. The only way to do that is to multiply it by 5. Now I have 10 on this side. Okay. Let me check my work because this is a kind of convoluted equation. I want to make sure that combustion equations can be kind of tricky sometimes because of that oxygen in 2 different places scenario. I want to check it. I did it right. So I have 4 carbons, 4 carbons. This is how I check sometimes. I use like 2 fingers. I don't know why. It's just something that I do sometimes. So I'm going to have 4 here, 4 here. I have 2 hydrogens here, but it's multiplied by 2, so that's 4, okay? There's 4 hydrogens right there. Here is 10, 5 times 2, oxygens. Here's 8 oxygens, 4 times 2. Here's 2 more oxygens, 2 times 1. So now that's 10. So here's my balanced combustion reaction. Okay. This is getting to be a long video. We're going to do one more. I told you guys I would do 5 from the random generator that you guys worked on in class today. Last equation. This one might be an easier one, but I just did 5 at random so that it would be exactly what you guys encountered in class. I know you did 10, but this video is already getting long enough. Okay. So here's my last equation. This one's going to be a pretty good one to balance. I'm going to list my atoms first. There we go. And then count. I have 1 and 4, 2 and 6. So I want to make my 1 turn into a 4. The only way to do that is to multiply it by 4. Okay. That doesn't change anything else because there's not another atom after that one. I need to balance my oxygens, 2 and 6. What's the only way to get 2 to turn into a 6? Multiply it by 3. I'm going to put a 3 in front of my oxygen here, and that's going to turn 6. Okay. So, a couple of notes. Remember that with the random generator, if you don't like the set that you got, the generated set. You can do them as many of times as you want to before you turn in your screenshot. That way you can practice. I don't want you to eat up all your time on your holiday weekend practicing, but I do want you to remember that you can come back to it and work on it until you feel like you've got 10 solid equations that you want to turn in. That way you get those 10 points that the assignment is worth. Okay, I hope this helps. Y'all have a really good long weekend. I'm about to post this on Google Classroom, and y'all can always private comment me on Google Classroom if you need any help. Bye.